the discovery of the universe's most significant structures has shaken the foundations of what we thought we knew about our place in the cosmos. Imagine for a moment that you're standing on the edge of an incredibly vast ocean, an ocean of space and time that stretches farther than any human mind could comprehend. But what if, within this unimaginable ocean, the very ground beneath your feet is far more complex, more chaotic, and more intricate than you ever imagined? This is the reality that scientists are beginning to confront today. A groundbreaking new study has emerged, casting doubt on everything we believed about our position in the universe. For decades, the prevailing theory was that our galaxy, the Milky Way, is part of the Laniakea Supercluster, a vast and relatively well-understood cosmic structure that spans over 500 million light-years. We thought this supercluster was the one to which our galaxy belonged, the one that shaped our movements through space. But the latest findings from a team of scientists in Germany have overturned this assumption, offering a new and radical map of the cosmos that shows our galaxy may actually be part of something much larger, the Shapley Supercluster. This discovery challenges long-standing cosmological models and fundamentally alters our understanding of the universe itself. It's not just a tweak in our cosmic map, it's a rethinking of the fundamental structure of the universe. This isn't the first time that science has had to rewrite our understanding of the cosmos. Throughout history, humanity has been forced to rethink its place in the universe. From the geocentric model that placed Earth at the center of the cosmos to the Copernican revolution that showed us the Earth revolves around the Sun, humankind has had to relinquish its assumptions about the universe many times. And now, it seems, we're facing another paradigm shift, one that challenges not just our place in space but our very understanding of how the universe operates. What's even more fascinating is that this new revelation isn't just about the Milky Way's place in the grand scheme of things. It's about the entire structure of the universe. The Shapley Supercluster, which our galaxy may now be part of, is one of the largest and most complex structures ever discovered in space. At its core, this supercluster is a massive, gravitationally bound cluster of galaxies that stretches for hundreds of millions of light-years, containing thousands of galaxies. But beyond its sheer size, the Shapley Supercluster represents something far more profound. It forces scientists to question how galaxies and other cosmic structures form, how they move through space, and how they interact with one another. Until now, cosmological models have largely assumed a universe that is relatively smooth and homogeneous, meaning that galaxies and other cosmic objects are evenly distributed throughout space. This assumption is the backbone of the Big Bang theory, which posits that the universe expanded from a singular point of origin, and that the cosmos is generally uniform, with galaxies drifting away from each other as space itself stretches. But the existence of enormous structures like the Shapley Supercluster complicates this picture. In a universe that's supposed to be evenly distributed, how could such massive and intricate structures exist? The very existence of the Shapley Supercluster challenges the idea that the universe is smoothly expanding and homogeneous, and it forces us to reconsider our cosmological models. The new study that uncovered this revelation used a novel cosmographic technique to map the movements of 56,000 galaxies, creating the most detailed and accurate map of the local universe ever produced. This map reveals a vast network of superclusters, voids, and other structures that were previously unknown or poorly understood. These structures, some of which are far larger than anything we've seen before, exert tremendous gravitational forces on the galaxies around them. The Shapley Supercluster, for example, is an enormous attractor that pulls galaxies toward it. This gravitational pull shapes the very motion of galaxies, altering their orbits and even the way they interact with each other. But what makes this discovery truly groundbreaking is not just the size of the Shapley Supercluster. It's also the realization that our understanding of cosmic structure is far more complex than we ever imagined. Galaxies are not simply drifting randomly through space. Instead, they are part of a complex cosmic web, interacting with one another through the forces of gravity, dark matter, and dark energy. These forces are so powerful that they shape the very structure of the universe itself, pulling galaxies into massive superclusters or pushing them away into vast voids. The existence of these superclusters, vast collections of galaxies bound together by gravity, has long been known to astronomers. But what's new is the discovery of a far more intricate and chaotic cosmic structure than we ever thought possible. The Shapley Supercluster is not just a large collection of galaxies. It's a colossal, gravitationally bound structure that represents the largest cosmic attractor known to humanity. And the sheer size of this supercluster challenges everything we thought we knew about the universe's evolution. When we think of the universe, we typically imagine a vast, sprawling space filled with galaxies, stars, and planets. But what we've learned over the last few decades is that the universe is far more intricate and interconnected than we ever realized. Galaxies are not scattered randomly through space, they are organized into vast structures, and these structures are interconnected through gravitational forces. These forces shape the movement of galaxies, pushing them towards certain regions of space and pulling them away from others. The Milky Way, for example, is not just drifting aimlessly through space. It is part of a much larger cosmic structure, and its motion is influenced by the gravitational pull of other galaxies and superclusters. This realization has profound implications for how we understand the universe's evolution. The discovery that the Milky Way is part of the Shapley Supercluster forces us to rethink our assumptions about the universe's history and its future. The Shapley Supercluster isn't the only massive structure that's been uncovered in recent years. Another key discovery is the Sloan Great Wall, a vast cosmic structure that stretches for over 1.3 billion light-years. This superstructure is one of the largest known in the universe, and its discovery has been just as revolutionary as the finding of the Shapley Supercluster. The Sloan Great Wall is composed of thousands of galaxies, gas clouds, and other cosmic matter, and it is so enormous that it seems to defy the very principles of cosmic expansion. How could such a massive structure form in a universe that's only 13.8 billion years old? And what does its existence tell us about the universe's past and future? The Sloan Great Wall, like the Shapley Supercluster, represents a challenge to the traditional cosmological model. In a universe that's expanding and cooling, it seems improbable that such massive structures could form so quickly. And yet, these discoveries suggest that the universe is far more complex and dynamic than we ever realized. The fact that these superstructures exist, structures that are far larger than anything we imagined possible, forces us to reconsider how we understand the universe's history and evolution. One of the most intriguing aspects of the Shapley Supercluster and other large-scale cosmic structures is their gravitational influence. These superclusters don't just sit there, passively waiting for galaxies to drift into them. They exert immense gravitational forces that shape the movement of galaxies across the cosmos. These forces are so powerful that they can alter the very trajectory of entire galaxies, pulling them towards certain regions of space or pushing them away. This gravitational influence is what makes superclusters like the Shapley Supercluster so important. They are not just collections of galaxies, they are the engines that drive the motion of the universe. The presence of these superclusters forces us to reconsider the idea of a homogeneous universe. Instead of a smooth, evenly distributed cosmos, we now know that the universe is filled with massive structures that shape the motion of galaxies, creating a cosmic web of interconnected forces. But what about the voids? These massive, empty spaces between galaxies are just as important as the superclusters themselves. These voids are not just empty, lifeless regions of space, they are active players in the cosmic drama. Just as superclusters exert gravitational pull on galaxies, these voids exert their own gravitational forces, pushing galaxies away and creating vast cosmic highways that galaxies travel along. The interplay between these massive structures, superclusters, voids, and the gravitational forces they exert, is one of the most exciting aspects of modern cosmology. It's a dynamic, ever-changing system, one that's far more chaotic and complex than we ever realized. And as we continue to map the universe and study its gravitational forces, we're uncovering more and more surprises that challenge our understanding of the cosmos. This new study, which used advanced mapping techniques to analyze the movements of 56,000 galaxies, has provided us with a glimpse into this chaotic and intricate cosmic web. The map shows a vast network of superclusters and voids, many of which are much larger and more complex than anything we've seen before. And it's this complexity that forces us to rethink our cosmological models. But it's not just about the size and complexity of these cosmic structures. It's also about the fundamental forces that govern the universe. For centuries, scientists have relied on the idea that the universe is governed by a relatively simple set of laws that dictate the movement of galaxies, stars, and planets. But the discovery of these massive superstructures and the complex interactions between them suggests that the universe is far more unpredictable and chaotic than we ever imagined. As we continue to uncover new insights into the nature of the universe, we're forced to confront the fact that our understanding of the cosmos is still incomplete. The discovery of the Shapley Supercluster and other massive cosmic structures is just the beginning. With new tools like the Euclid mission, the Vera C. Rubin Observatory, and quantum computing on the horizon, we're poised to make even more groundbreaking discoveries in the coming years. These tools will allow us to map the universe with unprecedented precision, shedding light on the complex gravitational forces that govern the motion of galaxies and superclusters. As we continue to explore the cosmos, we're likely to encounter even more surprises that challenge our understanding of the universe. But with each new discovery, we're inching closer to a more complete picture of the cosmos, and perhaps, a deeper understanding of our place in the grand scheme of things. It's an exciting time to be a part of the scientific community, and the best is yet to come.